All right. We're going to continue off from last class, right? So let's go to Kristen. You want to read the first one?
Students will use call to change what the value of this is.
Yeah. So we kind of need this method called call. It's part of JavaScript to change what the value of this is. And it's kind of hard to understand, just thinking about it. But once you kind of piece it all together with inheritance, then you'll see why we need this. Oh, it didn't turn on? I'm sorry about that. Yeah, that's why you're yeah. I was like, why is she looking that way? Because that's not even on. All right, let's go to Sandy. You want to read the second one? Yeah, so to be able to link two constructor functions together, that's the basis of inheritance in classic JavaScript. And we need the first objective to be able to do this one right here. 3, let's go to Haven.
We'll go over Hangman without constructors.
Yeah, so we're gonna go over Hangman again. That's from week 3, and then part 4. Let's go to Josh.
Students will talk about Hangman with constructors.
Yep. So we're gonna go over it, how to do it with constructors, like with inheritance, right? Well, not really inheritance, but with constructors, because there isn't really inheritance with objective 4. 5. Let's go to Nick.
Students will go over a Hangman without constructors.
Oh, number 5.
Oh, sorry.
That's okay.
Students will go over a tough recursion problem.
Yeah, so we'll go over some recursion problems, right? Like the hardest one we'll do today is the Fibonacci sequence with recursion, right? So we'll go over Fibonacci again, just the way to do it normally, right? And then we'll go over how to do it with recursion, right? Okay, so let's go ahead and start using call. So let me go to 35 right here. And let me just quickly open up javascript.info. Ebony asked a great question last time. She asked about like, what books do you recommend? That she was reading one. And I told everyone that, I just don't like reading that much. So I try to find, the reason why I don't like reading that much is because it's like, I do like to read, but just things that like get to the point, that actually teach you something. So here, this page right here, they give you real examples. They just tell you what it is right away. And what's kind of cool about this is if you find any errors or if you find something that could be written better, you can submit a pull request because this entire like book is on GitHub and open sourced. And which is why I think it's so great. View on GitHub. All right, so you can submit pull requests to this book. And if you're curious about who did this, it's this guy. It's this guy. I don't know who he is really, but. All right, great. Right, if you didn't start reading this book, please start. Right, it doesn't matter where you start or how much you do, but if you just get into the habit of reading this book, it's just going to make you really good at JavaScript. All right, so going back over here, let me just make this a little bit bigger, right? So this is where we're going to try to accomplish the first objective of call. So over here, we have an object, right? How many keys does it have? Let's go to Sandy. 1 key, nom, right? And it's set to Rob. And over here, and I know we went over this, but we'll just go over it again. Nick, what does this function do?
So it's basically
Oh, just talk about line 14.
Oh, okay. So console. So it's console logging this,
Mhm.
which I guess in this case is equal to the.
Well, this depends on what the function runs in, right? Because this changes, right?
Right.
Yeah. So that's good. We console log this.
On line 7, and then this it's setting this .hat, so it's setting a property of the tree.
Excellent.
Whatever the context of this is.
Great, right? So you're saying it's going to set a property on this called hat to be true, right? And it depends on whatever this is, right? Because that's the context, right? And then right here, if I do, and I showed you guys this, I just call update object. So I'm going to just open this up in the browser. So all we're running is this object and this function right here. Open this up in the browser, right? If I do ob, right, we see net name : Rob. And if I do update object, like this, it's a reference to the function. So this is what the function looks like, right? We're going to console log. We're going to console log the value. Can't click on it. Going to console log this. When I click on it, it takes me to that line of the code in the sources tab, right? So I could put breakpoints on it. But it console logs this, and it sets this.hat equals true. So how do I execute the function, Juthika? Perfect. The parentheses, right? We execute it. And why did it print the window right here, Josh?
Because you haven't clicked on anything or done anything with the window yet.
Good.
The window is this by default.
Perfect, right? Window is this by default because I executed the function in just the window, right? Directly in the window. So this is the window. And then if I type the word hat and press enter, Rob, what's going to be the value of it? True. So if I type hat, the value of it's true. Why did that happen, Kristen's row?
Because you say hat equals true for the window.
Perfect. As Josh mentioned, right? Josh mentioned that this is the window, right? Josh mentioned this is the window. And we put, and as Kristen said, we put a property of hat on this, and we set it to true. So that's why hat is true, right?
Hat's not a variable.
Yeah, because this is the window, right? Any variables you make in the window are on the window. Here, let me take a screenshot of this and then just go a little bit deeper to show you what's happening again. Let's go back over here. So if I type in the word this right now, Avon, what is it? What's going to show? Perfect, right? It's the window, right? And if I do this.hat, right? Aaron? True, right? So if I type in window.hat, what's the value of that, Sandy? True, right? Window.hat, right? So just like whether you type hat or window.hat, right? Hat is a variable in the window, so you could do window.hat. All variables made in the window are properties of the window, right? And you could even get window.inner height, and that's the height of the window. Let me just put this inside this, make the height smaller, type it in again, window.height smaller, right? So the window is the actual window, but it's also an object, which is very special in JavaScript, right? It's a very special thing in JavaScript. The other places where you see this behavior is like video games, right? You can get the screen size of like an iPad or something in Objective-C, and you can, because the size of the phone varies. So this is very special in certain languages. Let me just make this a little bit bigger and take a screenshot of this.
Value of this defaults to the window only if your function is defined within like HTML.
So like here, I'll give you an example. Just give you an example right here. Oh, what does that mean? Oh, I'm sorry. Thanks. I was like, that's fine, right? And then I realized I never do that. The image. Thanks, Andy. Okay. So we just discussed this, the window, the properties, variables, all of that stuff, right? Now let's change this code up a little bit, right? Instead of doing update object like this, right, executing directly, let's do update object.call and pass ob in, right? This object. We'll do update object.call and pass the object in like that. And let's try that inside the Chrome console. So I'm going to do update object dot call, right? And before I do that, let's print out ob again, right? That's what the object looks like. Right now, we printed out the value of this, right? What is this now inside the function Joe's row? It's the object ob, right? So when we printed out, when I did update object, right, it's console logging. The reason why this line is happening right here is because we're console logging this, right? And this happens to be the object, right? Because I did update object.call ob. When you use .call, you change what this is, right? You can do whatever you want. You can change what this is to whatever you want it to be.
The whole purpose of .call change this.
Exactly. It's the whole purpose of it is to change what the context is for this, right? It's very
Specifies. That's to go more into detail.
Yeah, exactly, right? Because if you don't use it, you're stuck with whatever this is set default, right? But if you want to change what this is, right, then you have to use .call, right? And so we're using .call, so because I want to update the value what object is. So if I do ob right now, how many keys will I have? Let's go to Derek's row. 2, right? What are those keys? Right, hot, hat, and name, right? So if I do ob now, we see name is Rob, hat is true, right? Whereas before it didn't do that because this was the window, right? It made a variable in the window called hat. Whereas now it made a property called hat inside the object instead of making a property called hat inside the window. And where do we use this in real life? You'll see very soon, right? The inheritance part. Cool. So let me send you guys this file. So you can just take a look at it, play around with it. Did anyone sign up for that HoloLens thing tomorrow? You did? Cool, Kit. You're going to it? Nice.
I'm gonna go, but I'm sure.
Okay. It's the HoloLens meetup. My entire Monday, Wednesday class, they're going to it. Trying to get them to be HoloLens developers. Right? Because I think it's freaking awesome. If you see videos of the demos, it looks like the future. Okay, cool. I just slacked out the file. If you want to go ahead, download this. Good. Why? Probably all Microsoft languages. They're guaranteed, like C# or something, which is fine. Later on in the class, we do es6, and it looks extremely similar to C#. Very, very easy to learn. es6. I mean, C# after we go through this class, most languages will be easy to learn, right? Except like Perl. Yeah, that's going to be hard to learn, but no one uses it, so it doesn't matter. Except for like DuckDuckGo. DuckDuckGo uses Perl. Okay. Nick, do you have it downloaded?
Yeah.
Open in Sublime?
Well, I just actually coded it from the screen.
Oh, cool. Okay, got it. All right, so we'll just put a timer for 10 minutes. Just go over it with your partners, and then we're going to continue on with call.
We'll see this is the so it's over 8 hours anyway. Not but then I don't know how it was. I don't know because it was the wrong process. So now if I try pushing this back in, it's still on my it says that it's kind of so this is this would now been.
Oh, cool. It worked. Nice. So 7 actually had a property. The 7 now 7 has a property of hat. That's crazy.
I don't know.
Yeah, how many students are in entry? How many students are in entry?
3 now.
3. Wow.
I know they were trying to get me to do 8, but
8?
with the reserve instructions, it's kind of it's it is. It's only 3. Yeah, I gotta like spread them out throughout the week.
Are you, is it
Yeah, not a week. Not a week. I might pop in your class after.
They wouldn't want me to do a bunch. If you got a question, just go ahead and raise your hand. Or write your question down. Yeah, if you call this dot something outside the function without, then it's going to update the window. Yeah.
Okay, now set it back to the window. The same name.
Yeah, what's up? Hmm?
So actually, you know, all
Update that.
direct,
So they update that. Yeah, it's hard to understand the true value until it's not really see the value.
Oh, this is from the previous one.
To update this object.
Yeah.
Oh,
No,
you
exactly.
just-
No, I'm
oh,
just
just
trying to
mix
show you
it
like
up.
simple
Here's
example
the-
right now.
this is
Because if I
the
show you
one.
full
That's like the
and
last
you see all the same
Right.
to understand.
But it push it into a group.
Here, as long as you understand what calls to it. Because I'm just trying to show you a simple example. As before we go to the actual.
Yeah. No, it's a computer hours there. I tried pushing this way, but so how do I get into that? That's
So you're just saying you pass the object in and then you update the object. And that is one way of doing it. That's certainly one way of doing it, but you can't do it that way. You can't use this. You'll see that we're not actually passing an object. Right? So here's an example, right? What if you didn't know? What if there was an object? Right? What if there was no object? You don't know what object. You don't know. There is no object. At that point, you can't like just direct it because there isn't a system. Right? So like that's what I'm saying. So you need this for like yeah. Yeah, those are two different, but they do similar roles.
Yes, array and just.
Yeah, I've used apply before. I forget. I use call mostly for everything. To use this, you have to kind of do some weird things. Call, but not I think call, yeah, call is probably the same thing, except for this. Yeah, you can pass it just to update this.
We only want the function on this.
It's kind of hard to see the value right now.
Yeah, see, like if I.
Yeah, go ahead, Juthika. What's up?
So when we said update object.create, then this was changed to object, right?
When we did this line right here.
Yeah.
Right here?
Yes.
Okay.
And then this was changed to ob, and later on when we did just this, then again it was window.
Yeah, so if you call this anywhere, right, outside of a function, it's going to guaranteed be the window, right? But if you call this inside of a function, right, it depends on where the function's being called, right? The function's being called in the window directly, and that's it, then it's going to be the window. If the function's being called within an object, it's going to be the object. If you do .call and you pass in a value, this is going to be whatever you pass in. Yeah. Cool. All right, guys, next problem. Next demo, right? So over here, it's the same, Will, just really quick, just pay attention to this one thing so you don't get behind. So over here, it's the same exact thing, except over here, this function's taking arguments, right? This function's taking in arguments, and to be able to pass values into those arguments, we're passing in 5 and 6 right here. So it's the same exact thing, except here we're taking in arguments, right? And to be able to pass values to those arguments and change what this is inside that function, we have to do it like this, right? .call ob 5, 6.
You're only taking in 2 arguments on the object. How can you put in 3?
Yeah, because the first argument is going to be whatever this is, whatever you want to change this is, and the next arguments are going to be whatever you want to update.
So .call essentially grabs that value and then get it passed in.
Exactly. And again, hard to see the value of this until we get to the inheritance, right? I just need simple examples that you understand before we get into them. Right, so let's run this code. Let's copy this in. Right, so if I do ob, it's Rob, like that. If I do update object, it's a reference to the function, does the same thing, except it just prints out the arguments, right? We take num, we take another num, and then we print them out right here and here. All right, we're doing the same thing instead of setting this .hat to true. So if I do now update object dot call ob comma, let's say 8, 9. When I run this, what's gonna happen? Let's go to Quasro. What's gonna happen?
It's gonna log on a 7 object Rob. Num's gonna be 8, num's gonna be 9.
Perfect. Perfect. Really good, right? So it's going to print out on this line right here. It's going to print out ob, right, which is name : Rob. And then on this line, it's going to print out 8. On this line, it's going to print out 9. And on this line right here, it's not going to print anything out, but it's going to update ob to have an extra key called hat, which is set to true. So let's run this right here. This is exactly what Quas said. And we take a look at ob, name : Rob, hat : true. Questions on what just happened, right? Repeating again, this isn't really anything until we get to inheritance.
Hat
Yeah.
was added to the object.
Because we pass object in as the first argument right here to update this, just like in the last example. The only difference is we pass in some extra arguments here to kind of fulfill these two. Right, so 8 is going to be num, and 9 is going to be another num. It's kind of weird because we don't see the first argument right here to be ob, but ob is being passed in as this inside that function.
So the first line under the function console log this on line 7 this is name is Rob.
Exactly, it's that object that we passed in right here.
And num 8, num 9. Then why don't you do ob down the bottom? It's hat part of ob now. How does hat?
Oh, just like the same thing, same thing as the last example. The only difference between the last example and this example is that we have some arguments in the function, and we're just passing in the argument values. Yeah, go ahead, Sandy. Yeah, .call. You use .call when you want to update what this is inside of a function, right? And so we're updating what this is inside the update object function to be op, right? Otherwise, it's going to be the window, right? And then we're passing 8, 9 because we have 2 arguments here, and we want num to be 8. We want another num to be 9. Okay, let me just take a screenshot of this, and then pass out the file. Great. So now we'll just do, and wait till Quad gives me a thumbs up, download the file, opens it up. Cool, got it. Do 6 minutes. Just going over the file with your partner, play around with it, right? Change the values. Maybe add some extra properties into the function to see if the object updates and has more properties. Pass in different objects.
So using .call doesn't permanently change the value of this for that function.
Oh no, it doesn't permanently, just changes it for that function call. For that function call, exactly.
So, yeah, the call function,
That's good, really good.
is that kind of like prototyping? Like,
That call, it's the prototype is more like
'cause you're,
saving saving memory, right? So like if we go back to the prototype over here, right, we have this constructor function that we use to create objects. And then we can put this function directly inside here. We could do this dot swim equals a function, right? Put some code in there. But the issue with putting functions inside a constructor function is that every object that's created is going to have the same function, and it could take a lot of memory. So the usefulness of the prototype is that any object that's created with this animal constructor function has like this shared thing. It's almost like instead of every single person, like I'm trying to think of an example of this. Like, let's say you have like a community center, right? A community center in your apartment complex, and then you have a pool table there. Not every it's unreasonable for everyone to have a pool table in their apartment, right? Because it takes up too much space. So you just kind of like throw the pool table in this community space, and then you can all share it. It's kind of like the prototype's kind of like that community center. Yeah. And so that's what the prototype's kind of used for, just so it's like a shared space, right? And then over here with .call, we're basically just changing, all it is we're changing what this is, right? So I could put that inside we change this in both examples. .call is used to change what this is inside the update object function. Put that inside both.
Because update object is just a function, but we put .call.
We can change what this is inside of it and execute it at the same time, right? Whereas if we just executed it, whatever this is going to be what this is. And in this case, this is going to be the window.
If you had just put, let's say the two numbers, right? And you called that function after.
Oh yeah, so if I go over to the second example right here, if I just did this right here, then it's going to print out on this line, what is this going to be? If I run this line right here, what is this going to be?
Well,
it's not going to be the object. What's it?
Yeah, it's going to be, like you said, the window.
The window, exactly, right? And then it's going to print out 5, and then it's going to print out 6. All right, and then it's going to make a variable, and it's going to make a property on the window called hat instead of the true, which is just a variable called hat globally. Called set true. Yeah, it's hard to kind of right now piece together like where it's useful, like I said before, until you get to inheritance. Once you see inheritance, then you see how calls used, and then you see how the prototypes are used, you see how constructor functions are used, right? But it just, if I threw all of that at you, it just isn't, in my experience, like putting all that in front of someone, they just don't understand any of it because it's just hard to piece together. Once you see all the parts and then understand each part and then see it all together, then it kind of, it's still hard to understand, but at least you understand all the parts. And now it's time, and then you have some, then you need some time to kind of piece it all together. Thanks for asking. Yeah.
This should be hat name rock true, Oh, I didn't do call. That's why. So there, so let's look at the change to as the
All right, guys, next part. All right, so we did go over this on Saturday, but you know, obviously this is going to take some time to really understand. Right here, we have this object. How many keys does it have, Aaron? Okay. Four keys, right? Name, hat, hoodie, water bottle, right? Almost, right? Gatorade, right? And then over here, we're making another object, and we're calling object.create and passing in ob, right? So what we're doing over here is we're cloning the object ob. We're cloning it, right? So another ob and ob are completely different objects. They're completely different. They are linked though. They are linked though. So another ob's prototype is set to object right here. Let me write that down, right? So clone the object named ob. Another ob is empty, but its prototype object is ob. So if you call name, if you call another ob dot name, it looks for name inside another ob, doesn't find it, then looks at its prototype and finds it inside that object, right? So let me just show you what happens, right? So let me just go to see this from scratch. Is that a window? So I'll just make this object, right? It's just a plain object, and now we'll make variable another object. And in this example, I'm going to do this kind of wrong, right? And I'll just do ob like this, right? If I do another ob dot, let's say, jacket equals false, right? And how many keys does another ob have now, Rob's row? 5, right? Right? Another ob has name, hat, hoodie, water bottle, and jacket. 5 keys. And if I do ob, how many keys does ob have now? 5, unfortunately, right? We didn't clone it, right? Ob actually has jacket too, even though we just updated another ob, because when we do this line right here, this isn't cloning it. We don't clone the object right here. We're just making a reference, right? So another ob is actually just an alias for this object right here, right? It's not, we're not actually cloning it, right? So over here, let me just copy this. This behavior is true for functions, for objects and arrays in JavaScript. When you have functions, objects, and arrays, you can't just clone them by setting it to a new variable. That's not cloning. You go ahead, Josh.
Well, just say this, in that, it works both ways. Another ob equals ob and ob equals another ob.
Mhm.
So if you change one, then the other one's equal to the other one. Is that am I right there or no? So I'm saying, so you,
Yeah.
that
Yeah,
one,
no, you.
another ob equals ob.
Mhm.
Therefore, ob also equals another ob. So if you change one, then it changes the other. Is that how that works or no?
So are you talking about the transitive property? It's been so long since I did that.
I'm trying to understand what it is. I mean, you can explain it, I guess, keep going, but I just.
Yeah, I have to.
I'm trying to make sense of why it does that.
Yeah, it's just the behavior of JavaScript and many languages. Many languages work exactly like this, right? Where if you set a number to a variable and you make another variable and set it to that same variable, it actually clones it. For numbers, booleans, strings, like it gets cloned in that way. But for objects, arrays, and functions, they're just references. They're just references, right? So let me just take a screenshot of this, paste it in. Everything I'm going over right now is just for inheritance, right? So if you actually want to make a clone, you do object.create instead of just doing ob like this. You do object.create ob. So let's try that right now. Let's copy this. Paste that in, right? And we'll do another var, another ob equals object.create. An object.create is part of JavaScript. Pass an ob like this. And now if I do another ob dot another ob like this, we see it's completely empty, has nothing inside of it. We open it up, there's a proto property, right? Which the proto property points to the prototype, right? The prototype is just an object. We open that up, right here, we see this right here, right? This is the object. So we cloned it in a unique way, right? And if we do another ob dot jacket equals true, right? Another ob has jacket colon true, but ob doesn't, right? So in this way, we've cloned it, right? There are other ways of cloning objects. This is the preferred way of doing it in JavaScript. You can clone it by doing json.stringify and taking the string, putting into a new variable, and then doing json.parse on it. That's another way of doing it, but it's kind of expensive, right? Expensive meaning it takes memory, like it makes your computer hot if you did a lot of that. Whereas this isn't that expensive to do. It's not going to take that much memory compared to like taking an object, converting it to a string, and then taking that string and converting it back into an object. Right? So let me pass this in. So right here, we clone the object, right? I'm just showing you exactly what I just did. So let me send you this file. And don't worry, the next few examples are inheritance, right? So you'll see how it pieces together right there. And we're covering this now, and we're actually going to cover this again in week 18, 19, but using the new version of JavaScript. So right now, this is hard, but in the new version of JavaScript, it's so much easier. The syntax is so much simpler to understand, right? With this syntax, this is kind of hard to understand, but with the new syntax, it's so much easier to understand. Okay. Rob, give me a thumbs up when you have it downloaded in Sublime and Chrome. Cool, got it, cool. Just go over it with your partners for 7 minutes, and then we'll go into inheritance.
I should have known that. I don't read the names anymore. It's all interesting. So do all that. Another.
Take the number on. Okay. You open it up.
Yeah, and so if you clone an object, that object's cloned, you can still access the value of any properties that were previously defined on the object. Yeah, they're not explicitly defined in the object itself.
Yeah, I guess it is. It's a clone package, but then it becomes its own person.
Yeah, well, what's interesting to me is that, like, you know, if you just like put out another odd, you know, it doesn't show those properties inherited from the prototype. But it's another like odd dot or whatever. So if you find it, it still gives you that odd. Like it's that maybe. I think it's kind of interesting that they don't just explicitly, like they didn't just explicitly, you know, create a key value pair.
Right.
There's some reason for that.
Yeah. Oh, yeah. There you go. But it, prototype is a little bit different than object.
Okay, so actually what we're seeing is prototype
There's also something. Yeah.
Okay, questions on this file?
So.
Yeah.
You update then the prototype or whatever. Because I did.
Yeah, so if you want to get rid of it, let me go to that other file. Okay, so we have ob, right? And if I do ob dot prototype, Oh wait, no, I'm sorry. Look at that. If I do this ob.proto, right? It's object. It's this thing called object, right? And if I do another ob.proto, it's ob. So if you wanted to update, if you wanted to prototype over here, let me just, I'm taking a guess right here. I forget how to do it off the top of my equals, let's just say empty object. That was wrong. Yeah, so you do underscore, proto, underscores, whatever you want to set it to, right? If you wanted to update it. You do that with inheritance. With inheritance, you update the prototype, right, of an object. Yeah, I mean, Josh asked it. Yeah. And
How would you update it? How would you make it so another ob would have it not in the prototype? But in the
another ob dot, let's write this down, how to update the prototype of an object. Ugh, I screwed that up before, but this is the prototype. Totally screwed this up. Sorry, refresh this. Paste this in, just do it. Forget everything. Another ob equal object.create. Right, another ob looks like this now. The proto property is this. The prototype is this right here. Right, just now if I do another ob dot underscore proto underscore equals name colon Nick. Look at another ob. We just updated the prototype. Right, and then I was just answering a question. No more. No more. I'm not trying to make that into something. Okay, now where everything comes together, right? Where everything comes together from what we just learned, right? Actual inheritance. So over here, in this example, I have a constructor function, right? What's the name of this constructor function, William? Person, right? How many properties does it have? 3, right? 3. So if we create an object with this constructor function, it's going to have a new property. It's going to have an age property. It's going to have a height property, right? And I purposely name them different in the arguments. So I name these properties different from the arguments, just so you see the difference. But if you have an example online, these arguments right here are going to be the same as the properties. I just named them different so you could see the difference. And then over here, we're updating the prototype of whatever object that's created with this constructor function, right? We're updating the prototype. So we're adding a property to the prototype called scream, and it's going to console log person's name, right? Whatever name was set here, plus an exclamation mark, right? So, so Sandy asked a great question about the prototype and talked about it a little bit. So this constructor function, right? It's used to create objects. Now, what we could do is we could do this name equals. We could do, you can do this. You can do lines 6 through 8 right here. That's fine, right? The issue with doing that, doing the following, is that every object that's created with this constructor function, with this person constructor function, is going to have a property called scream set to a function, right? And instead it's better to do person.prototype .scream ... equals function because you save memory. So let's save memory. So I talked about it with Sandy a little bit, and let's apartment complex, right? Tons of apartments. My apartment's so small, right? They're increasing the stupid rent, never mind. But they're increasing the rent all over San Francisco. Ridiculous. But so small, and I can't really have anything that much. And I can't have a foosball table or a pool table, right, or anything because it's small. And but there's like a community like center, right? Like there's like a little building where there's like a library and there's like a pool table and stuff like that, right? So we all share that table, right? We don't each have that pool table in our apartments because it's completely unreasonable to have like that part of your apartment. So we all share that pool table in that common space. And that's what the prototype is like. The prototype is kind of like that common space that all these have, right? Because it's unreasonable to kind of put it in every single object when you just need it in once, right? So that's what's happening right here. Right? We have a constructor function. We're going to create objects with it. The objects all share this prototype object with the property of Scream inside of it, which is a function. And now we have a function called answer, right? Now you see call right here. We're passing this, we're passing arguments here. Everything's coming together, right? So we have a function called dancer. So a person has a name, they have an age, they have a height. That's just people, right? That's people. That's a person right there. And then let's just say you're a dancer, right? You're a dancer, but you're also a person, right? You're a dancer, but you're also a person. What does that mean? Dancers have, right? They have a dance move, right? They have some kind of dance move. And then, but they also have name, age, and height, right? So we're going to connect these two constructor functions together now, right here, and call. So we're saying this dot move equals move, right? So any object that's created with this constructor function will have a property called move, right? And then the prototype object, right? The prototype of this object is going to be object with name, age, and height, made with person. That's what we're doing with person.call, right? Person.call, we're passing in this, right here. We're passing right here, and we're passing in the arguments NAH, which is going to be the name, age, and height. That's going to be passed into this function right here, right? And if you see here, there really is no other way of doing it. There is no other way of doing it. You can't pass an object directly and update it, right? Everything we just did in the previous examples are coming in this example right here. So let's just go over this again. We have a person. A person's going to have a name, age, and height, and they're going to have a common property called scream, which is a function right here where they scream their name in the console. And then over here we have dancer, which has a property called move, and then also has name, age, and height. But it's not inside the dancer directly. It's inside the prototype object, is a person object. And then over here, right? Over here, we're not done. We're doing dancer.prototype equals object.create person.prototype. This is the way to update. This is the way to update the prototype. Oh my gosh, I was kind of half right in the way I was showing it before. This is the correct way of doing it. So we're saying dancer.prototype equals object.create person.prototype. So what we're doing with object.create is person.prototype is an object, and we're cloning that object and setting it to that prototype over here. And then we're adding a custom function to the dancer's prototype called spin, spin, spin right here. And here we're making a new dancer object with the dancer constructor function. We're passing in flip, right? And Fernando, you, right?
I wish I could flip.
I'm sure you can if you tried. I can't. Flip, we pass flip in here, so that's the move property. And then Fernando 2277 goes into name, age, and height. So let's just try this. I'll just copy all this stuff into the console. refresh this. Right, so we see, well, let's take a look at this object right here. So we see D right here. I open, we see name is Fernando. We see move, age, and we see height and age. And we see the proto property is set to the person. I mean, we see the proto property has a dancer in it inside of it, right? This is the prototype of the dancer object. And if we look at the prototype of this prototype, it's the person's prototype. That probably was really confusing. Guaranteed. Just go back over here. Person constructor function, right? Person constructor function has a prototype called scream. We have a constructor function right here, right? And over here, we're saying this.move equals, right? So it has a property called move. And then what we're doing is we're making properties called name, age, and height using the person constructor function up here. Right, so we're using the person constructor function, right? We're basically executing it, right? We're executing this.name, this.age, this.height inside the dancer constructor, but we're passing in this that was used inside the constructor function on line 22. And then on line 27, right, because we want dancer to have its own prototype, right? We want it to have its own prototype. So we clone the person prototype and set it to dancer.prototype, right? Because we don't update the person's prototype. If we don't have line 27, we're going to be up to person prototype. So the person prototype would have a dance function. So we have to clone the person prototype right here, so that the dancer has its very own prototype. And then over here, we're adding a dance property to the prototype function, prototype object of dancer. And then we're creating a dancer object right here with it. This is very confusing, and a lot of people don't do inheritance in classic JavaScript for this very reason, that it's very confusing. The new version of JavaScript, this actually is so much simpler to understand, because it's written it's written in a very simple way. This is very confusing because it's using object.create, we're using prototype, we're using constructor functions, we're using call, using .prototype, right? We're doing all these things, so it is confusing. Over time, this will be easier. We're going to go over it again later on, week 18. So let me send you guys this file to look over. I understand that this is confusing. Which is why I wanted you guys to kind of jump into this book, right? Because they have an entire chapter on inheritance and prototypes.
That's written based off the new or old version of JavaScript?
Both. They show you the old version and the new version. Okay, just sent you the file. Joe, give me a thumbs up when you downloaded it, opened it in Sublime. This took me to understand. I'm just being straightforward, because it's not really very clearly anywhere other than this website. I just could not find a clear explanation of, I was trying to find, how do you do inheritance in classic JavaScript, right? And people go over the prototype, they go over constructor function, but then I was like, how do I connect them together, right? And then there was nothing on it, even on W3 schools and that Firefox, that Fire MDN, right? I couldn't find it either. And it was frustrating until I found that page and I read through it and I was like, that's how you do it. And I played around with it. It took me a week to really understand this, unfortunately. So just so you have some context, if you feel confused, it took me a week to really understand this. Okay, you guys 15 minutes to look it over with your partners, go over it. Use your partner to kind of bounce ideas off of. Two, it's gonna be hard to kind of just stay in your head and do this. I'm gonna make a breakout room for everyone online. Join if you'd like. What's up?
So you did like var another ob equals ob.
Mhm.
Do you remember that?
Yeah, yeah.
And then you did another ob dot jacket equals true,
Mhm.
and then ob also had jacket equals true.
Yeah, because the ob was a reference in that case.
What's that called? That's not called inheritance. What's that
No, it's called referencing.
That's it.
You're referencing an object
Okay.
in that case.
Awesome.
Yeah, thanks for asking that.
Oh, it's got, yeah. What you said. Is it?
Hey guys, blacked out the next activity, but we're gonna go on break for the next 18 minutes, 30 seconds. Right? You can rest if you want, but just break time right now.
What's up? Oh, it's good so far.
I did know. Yeah, but I don't know if that.
You're more of a Laravel.
Yeah. Oh, yeah.
And I don't know.
As in earlier activity.
I can do, but when you don't use it, you forget the name. Right, and then setting the path correctly, that's like the hard thing. Right, so how do you put a base on it? Yeah. Now that they're, yeah. Yeah,
Would you call it? Would you call it? But this is just in this function. How's it gonna be? Oh, my. Well, and then it's gonna actually, this is not gonna be good.
So now the parameters we have to change between inputs and the not there. And the current argument will be here, and I'm telling this.
I got it. But we're having now the
Yeah.
is whatever it is. Spin. Where did you-
I want to made on this.
It said
This document. There.
the move is important. Oh, and I know the and I know the HP attacks. And I mean, oh yeah, I'm doing it now. Right? That's just because I need time.
Okay, guys, there is an activity. I posted it before the break. It's 13 inheritance activity. You can use that, the file, you can use 12 to guide you significantly. If you have a question on what something means, raise your hand. I would love for you to work with a partner on this. So like maybe one computer, you could pair them, ideally. So I'll give you guys minutes and see where you're at. This is actually what I did originally. This is what I did originally until the student said something. Yeah, we should change that. I did this originally. But then the student said, well, if they, I put a button on the Pikachu prototype, it updates the Pokemon prototype. And this is so we have to clone this object. And it's a Pikachu prototype, so Pikachu has its own prototype. And Pokemon has its own prototype. Right. But if you take a look at Pikachu prototype, it's going to be Pikachu's own prototype. Prototype change, if you look at the prototype of the prototype, it's going to be the Pokemon prototype. That's why they call it prototype. Or prototype chain. It's actually a chain all the way up to the very, very top, right? Like of where everything is, right? Oh, it's gonna update. Yeah, so if you do Pikachu, you can create, then you won't be able to call it. Oh, I want to do objects, yeah. In there, because it's not functional. You can't. I'm sorry. So you're trying to, what you're saying is you want to take all the key value pairs of Pokemon prototype, put that actually inside this Pikachu constructor. I don't know. I mean, what you can do,
I
what
want
you
that, just viewing for that, I want people to do it.
yeah, you're actually just cloning this and setting that to Pikachu prototype, right? So you get Pikachu dot, when you look at the object that's created with Pikachu, the gorilla property, it's going to be this dot object, right? And then if you look at that prototype, it's going to be Pokemon prototype. Yes.
Then this prototype will be the.
And then if you look at the Pokemon prototype at that point and you look at the prototype property of that, it's going to be object. And then if you look at the prototype property of that, it will be prototype. Yeah. It's a very yeah. You completely understand. That's amazing. Hey, what's up? Yeah. Yeah, let me just open up something. Yeah, what's up?
So these three things,
Mhm.
am I making, for example, like the constructor function called Pokemon with these three keys?
Exactly correct. So it's going to be, so what you're doing here is going to be similar to this person. So yeah, see, a person has three keys. The Pokemon is going to have three keys, but different than this. Right, so you're going to make a constructor function with these keys inside of it.
And I was just thinking, we could go back to the other one.
Yeah, sure. Mm-hmm.
So for the names, it's going to be a string.
So actually, we never worry about the types. You just set them, and when you actually create an object with a constructor function, that's where you pass in like the value, the string or array. Right. So this has no idea about the types.
Gotcha. Okay.
Yeah.
All right.
Good question. No problem.
Sure. It's calling itself.
Hey, what's up?
Have you heard about the Marconi protocol?
The what?
The Marconi protocol.
Let me just look it up. I've heard of that. That's a math though, right?
I do not.
Marco
It's like,
protocol?
No, Marconi.
Or you gotta type it in like Markov
Like-
chains. That sounds like math.
Marconi like this.
Yeah, I haven't. So, Ethernet protocol. It's
Yeah,
crazy.
you can use that in blockchain.
New blockchain while using programmable to enhance security and privacy. Sounds insane.
You can find them in the ICO too.
Using programmable to enhance security. Get started. Interesting. Let's just take a look at the get started part. See, see how dangerous this is? Crazy. It's so easy to get scammed. Let's see right here.
They're like making this thing.
Oh, the kids.
Yeah, they look like kids.
it's your kids' friends. Wow, you
Yeah, because they have like a second round.
where are they? San Francisco?
Yeah.
Interesting. If 11 to 50 people. Yeah.
You're just 11 of them.
Yeah, I don't really understand why, like how like us, like I know what a smart contract is, but I don't know what a smart pocket contract is. That sounds crazy to me. I don't know what that means.
They want to change the internet protocol.
The internet protocol, it's
Yeah.
pretty
Pretty big deal.
big deal if they did that.
Choosing the question.
Very cool.
This is insane. I don't know how to use this. Like whoa, like how it's pretty. Because as a developer, I don't really think about the bits or the packets, right?
Yeah.
Especially since I'm not in a memory. I don't have control over the memory in anything I write usually because Ruby, Python.
Yeah.
Python, even Java.
This one is the low level one.
Yeah, it's like create a network filter. Interesting.
Yeah.
Deep
They're
packets.
using IPv6. So they
Decentralized
got like 500K on the second round.
It's really like, what's the use case? Like, what would I be able to do with it? Like, what are the problems in network security that this can solve? You know, like that's a question because I don't really understand. It's interesting to bring it up. Yeah, it's great. I haven't even heard of it. It's pretty crazy. This is what I'm doing. This is what I'm interested in right now. Called ZK Snarks.
What's that? Oh.
And so ZK snarks, it's imagine you have something. Okay, you have an API, right? And you don't want the API is actually it's not an API, it's a smart contract, right? So just think of it. And you want to call a function in there. Check if someone's credit is good, right? So you call that function. I pass in your public key. I don't even know your identity. I pass in your public key, and to that function, it gives me back your credit score, right? Or you know what? It doesn't give you credit score at all. It just tells credit worthy, and it reveals nothing about you. No, your name, your social, nothing. It won't reveal any of that information. It just reveals that you're credit worthy. Not only that, the developer itself has no access to that information. No one has access to the information. The protocol, the contract you write has that information, but does not reveal it to anyone ever. And there's no way to get it out, right? But it guarantees that information. It's guaranteed correct. Like I can check your credit score without knowing who you are at all. No about you, other than the public address, which I don't even know who that belongs to. I just know your credit is good. Right? That's what the power of it is. So a lot of people, even people outside of blockchain, are really into this right now. Even people who are like Bitcoin stupid, Ethereum stupid, they think this is amazing. Right? It's pretty nuts. And Zcash uses some kind of element of this. Zcash. They use some kind of element of this in their thing.
I don't know what happened, but I made like an
Let's see. Just get the timer up. No, it's good. You need more time. I see people. You see Pikachu? The prototype is.
So I was confused.
So let me take a look right here. You have Pokemon. That's good. And then you have the Taction.
So in this one, you pass the parameter.
Good.
Okay, that's here what I originally, and I was confused.
Looks good. Okay, so.
Like how does this happen?
This you're calling your function directly, right? You're just looking inside of it. So that's normal. Yeah. So it should, but it's not going on forever, then, right? So if you take a look at the prototype, I do. It eventually stops. It looks like it doesn't keep dot. Proto is this, right? Proto. Dot proto.
Oh, it's going up that tree.
I go up maybe one more. And then it's eventually no. You eventually get to no.
But I saw way more.
Yeah, because you're looking at the actual object. You're looking at the actual prototype and put stuff inside of it. But if you just look, it eventually gets up to null. Null.
I was looking for that tag.
So the null is top, right? And then the one below that is the object. Yeah, but you're executing the actual. You're just trying to Pikachu.
Oh, okay.
If you actually do make objects out of it, right, then you'll see it a little bit easier. But don't forget there's a step over here. Don't forget this step right here.
Yeah, I was just going.
Yeah, yeah. Don't forget that step. That's an important step. Okay. Thank you.
Yeah. So this is new, yeah. Great. But then, yeah, so then I create the view. So yeah, I did it again. My question was, I think though from this is why are these labeled?
I'm pretty sure this one is your parameter.
Oh, okay. It's okay.
They can be named differently.
Okay.
As long as the number of, well, you can skip the number after the master. So if you pass the name, you should pass the name.
So this is all correct.
Yeah, Pokemon.
Yeah.
But this one will be the on. This is the object that is going to.
Right. So this
So you don't have to do this.
So y'all have to do
No, no, no. This is where
Okay.
don't do this. You can create that one later on using the Pikachu.
Yeah.
You don't have to do this.
Yeah, but the one thing, the one instruction about is we gotta create. Add the attack function to the random attack.
Yeah.
Console log.
Yeah, this is it. We're doing it. So create
But at this point, you should just call the function that we created that's console log. It says create a function because then at the end it two objects that call the attack.
Yeah. So you have that this function here.
Right, but it's take this array. Or what? I mean, what?
When you create that Pikachu later on, you submit that array for that. Yeah. So you're passing in them. Let's put V here. Oh, okay. So this is the M.
So how do you pass through the array and call functions?
So you have to do it in the function.
So here, like attack equals.
So you have access to the array, right? So this array is an array, right? This that. Oh yeah, that's only the last. Right.
It just looks like you put
So it's like this that attacks and random. This will just generate that, right?
This will generate one random attack.
Yeah, right. Index the array, right? You just have to.
So it's multiplied by the.
Yeah, so this one will get index. I'll just bring it up. A random index. And when you call from
Show me where that is. You could go into your task.
Okay. Okay, yeah.
So this object, which is Pikachu, yeah.
I like
We're inheriting the function.
And then I'm creating
Create other functions.
Now connect the two and then make two objects.
Oh, okay. So you don't need to create another. Oh, okay. Oh, that. Oh, okay. Just call that only. Call it. Okay.
we just remove that folder.
So is that right? Is that single?
So the constructor is
No.
Spit out. So this is wrong direction. Oh, you're passing an array, right?
Now we should push it back.
Oh, okay. So,
Yeah, I'm passing an array. How does it get random access? It just knows to be randomized. Even if we
No, you're calling that function. Didn't create.
okay. No. See if I'm on the right track here, and then you call the attack function. But you actually put it like a function here.
No. Now you have to, so you can do pick that attack.
But can I just cancel it?
Yeah. Pick
No, okay, is it? I'll say it's spelled right.
Oh, yeah, then you have to call it that attack, right? Then that's calling that code.
Oh, yeah. We mean calling the attack. Putting.
So you have to put the parentheses right up into the.
Oh, here.
Oh, wait, what is the time? You don't have to call it because it's already called this. What should that be?
I could do 4 more minutes. Does anyone raise your hand if you want 4? Okay, we'll do 4 more,
And you can do the.
and then we can go over it then.
Okay, yeah. I got it.
You really need to understand this because the new code is saying that
Yes.
it's like. You want to know what's going on?
Yeah.
I mean, this is how it's going on. Yeah. Is it random?
Yep.
When you write again, this didn't have a color.
Yeah.
Oh, yeah, there you go. Yeah. I would because when you see functionalities, when we code, we don't separate classes. We just code like do this, do that. But when you don't get computation and you open the code, it's fast and all that. Yeah, no, and the approach is. I think the order.
This is what they this is what
That's how we share.
All right, guys, let's go over it. Okay, so let me just read this. Yeah. Okay, so let's get the activity. Make it a comment. Go up the top, make a poke structure function that makes an object with 3 keys in it: name, HP, attacks, and then name is a string, number, attacks is an array of attacks. So let's start it off. Let's go to Rob's row. Okay.
Function. Then write this name, comma, HP, and attacks.
Good. I'm just going to name it like that, just so it's going to be easier to see. And then what goes inside? Go ahead.
Those 3 arguments, this name equals name, this HP equals P, this tax equals tax.
Cool. And I'll put S over here. Great. Excellent. So now we just took care of this right here. And a great question asked during the activities was, how do I guarantee that this is a string, this is a number, this is an array? Although was not a requirement to do that. If you want to do that, what you could do is you could say dot is string or something like that equals false. And then you could say nom. You could do this dot nom name equals Fred. Else that, right? So in case they don't pass in a string here, you're set to the name of the object to be Fred, right? I mean, that is something you can do. I'm just gonna comment that out. Right, you don't have to do that. That's not part of the exercise, or it's not something people do normally. How to guarantee that nom is a string.
Tells you guarantee that HP is going to be a number.
Yeah, there's a is number function, and then there's like an is array function. So you do like you do a few of those if statements in there. Good job, Rob. Bro. And then add the function to the prototype of the Pokemon constructor function that chooses a random attack from the Pokemon's attack property and console logs it. Let's go to Haven's row.
Equals function empty parentheses. Firstly, I made an intermediate variable that I call attack or ATT.
It's at the index, yeah.
Equal to this dot tax.
Oh, let me just change that. Okay.
And then square brackets, math dot for.
What I'm gonna do is I'm gonna var ran index, and I'll just do that math.floor. Go ahead.
This is math.random. Empty parentheses.
Yep.
And it would be multiplied by this dot tax.
Excellent. Take this ran index right here. Cool. And then at the very end,
console log this dot name. And I added that to a string that I used with a space on each side, and plus attack.
great. So why did this dot attacks instead of attacks here? Why did you use this docs instead of the word attacks?
I just did because it seemed like attacks wouldn't have been defined in the scope of that.
Very good, right? This dot attacks is the array. Attacks would be a variable that isn't there. So the variable attacks does not exist, but this dot attacks exists, right? Because if you did attacks, it would look for attacks maybe in the window, right, or something. But this dot attacks is definitely there because we set it over here, right? This dot attack equals whatever we passed in. So we have to use this dot attacks here. Good job. All right, so make another constructor function named Pikachu. In addition to everything in the Pokemon construction, it has a property called voltage, which is a number. So let's go to Kristen's row. How would I do this?
This dot voltage equals voltage.
Perfect. This dot voltage. Oh, sorry.
Pokemon dot call this
Call this comma and HA. Perfect. Right, so we're just like what this does, this following line this one line is like we put 3 properties here in the function, right? Do it right here on line 40 is like we took these 3 lines and we put them right here on 33. That's what this one does right here. Okay, connect the Pokemon constructor function to the Pikachu constructor function now. How do we do that? Let's go to Aaron.
Pikachu.prototype equals object.create parentheses Pokemon.
Excellent. Very good. And so Juthika asked a really good question. She asked, why don't we just do this right here? Like, why don't we do this right here, right? The issue in 46, go ahead, Juthika.
This is like referencing the Pokemon prototype.
Perfect. Right, we'll stop right there. Where Pokemon, you can't just duplicate an object by setting an object another object, right? Because otherwise, what we're saying right there, Pikachu.prototype is referencing Pokemon.prototype. What that means is when we add the Pikachu prototype, it's going to add it to the Pokemon prototype, right? So if we add something like a Pikachu, right, on the Pikachu prototype, so all Pikachu objects have like a say Pikachu, and all of a sudden all Pokemon objects are going to have a say Pikachu function. That doesn't make any sense, right? Lost the inheritance. Whereas here on this line, we're just cloning. We're cloning Pokemon the Pokemon prototype object with object.create and setting that to Pikachu.prototype, so that any properties with the Pikachu prototype is just for the Pikachu prototype. That's it, right? Whereas this reference, right? Okay, let me just write that down. We don't do this. Yeah, let me just put this. We don't do this because otherwise the Pikachu.prototype is reference to the Pokemon prototype. And anything we add Pikachu prototype is going to also be put on the Pokemon prototype, and we'll lose our inheritance here. And now make 2 Pikachu objects and console log their name, voltage, and HP. Call the tag function on. So let's go to Sandy's row. Oh, well, we're just making objects, so we could just do var and just go ahead. We gotta pass in these 4 arguments right here.
Vaughn, quick question.
What's up, Fear Fernando?
So you know how for Pikachu you have for the function Pikachu it says vol and then NHA, right? Vol for voltage. But how, like, you know how you have NH, where do you have that defined as opposed to?
I'm not defining it anywhere. I'm just where am I defining it? I'm defining it on line 31. This is the definition. Right?
Okay.
I'm just establishing these arguments right here, and then I'm passing them here.
Okay, I guess I just got a little confused because for the Pokemon part, you had them defined for this dot, this dot name, this dot HP, and equals nam age attacks, as opposed to for Pikachu, you don't have that same process.
Yeah. So I'm kind of doing that here on line 32. Taking vol, I'm doing this dot voltage equals vol right here, but then over here, I don't want to copy and paste everything here, right? Here, that's repetitive. So what I'm doing is I'm doing Pokemon.call. I'm passing this in, right? So we up this, right?
Right.
In this context right here. And then I'm passing in some arguments, NA, right? And then it's going to update this right here using reasons right here.
Okay. Thank you. I just wanted to make sure.
No worries. Yeah. So over here, let's pass in a name, HP, and attack, right? An attacks array. So we'll do George. Oh yeah, voltage. You're right. Thank you so much. So we'll do 400, comma George, comma that was the name, and the HP would be, let's just say 100, comma attacks would be shock, right? Tackle, and then Thunderbolt. Oh yeah, quick attack. We'll do that for the next one. Right. So for voltage, we'll put 500. Fiona, keep 100, and we'll play quick attack. I think this is electric shock. Great, and we just call this one A P dot attack and A dot attack here. And if we just open this up, it says George used electric shock and Fiona used thunderbolt. And if I do this, I do P dot attack again. George used electric shock. Well, time. George used electric shock. No, George used thunderbolt. Okay, good. I was like, we do something wrong. All right, so this took me a week to kind of like I was also finding the information, so that was hard. But in all seriousness, if I presented this right now, and if I studied it, it would take me a few days to truly understand, around with it and stuff. So don't feel like you have to understand all of this right now at this moment. Play around with this code, right? I'm gonna give you like a in-class assignment next class, right? / homework. It'll be a homework / in-class assignment that we just work on in class. That's gonna like help you guys just a little bit better. So what I'm saying is like, it's hard. It'll take a little bit of time. Okay, so go ahead. Yeah. Mm-hmm.
When you said when we call Pokemon.call and this, yeah,
Mm-hmm.
right. You get all the properties of Pokemon. This dot name, this dot HP, this dot attack.
Mm-hmm.
Then why do we need 48 or something?
Oh, this one?
Yeah.
Yeah, the reason why we need line 8 over here is it allows us to access the attack function. This is the attack function. So that's why we need line 48 over here. If you don't have line 48, then you don't have the attack functioning. This is what connects it. This is what does the connection.
And if you want to call just one random there down on the while you're calling, along with the object that you have created.
Yeah, so this is the new object.
Yeah. So there, when you console.log, all attacks come. Like if you console.log p dot attack, then all the 3 attacks will come.
Oh, that's fine, right? Because p dot attacks is all the attacks.
But if you just one random attack, since you can access it.
Well, we can call the attack because that's what that does, right? The attack function gives us one random attack from the attacks property right here. You could also do that manually outside. You could do p dot attacks times p dot attacks dot a length times math dot floor that and put that into p dot attacks, and that would do that too. Yeah, go ahead.
Is there like a particular reason or advantage why we define function attack on the prototype of Pokemon as opposed to Pokemon itself?
Yeah. So why do this dot attack equals this function right here? Yeah.
Oh, right. You explained this earlier.
Yeah. So because to save memory, right? It's like the pull in the common area example. Just too much to keep in everyone's apartments. Great. Most people don't understand any of this, and it's a hard interview problem, and most people get it wrong. So I'm hoping that it sticks. I think it will. It's hard, and you'll think about it, right? So I think if this will stick in your heads, you'll make flashcards on this, and you'll get this interview question correct, right? When people ask you how to set up inheritance in classic routes. All right, so now we'll go over like a computer concept, recursion. We've already kind of went over this. Let me hide this for a second, for example. Okay, so doing exponents, right? Exponents. So what's an exponent? I don't know what I'm doing. Right, what's an exponent? So I say 2 to the power of 3. What's the value of that? 8, right? But what's actually in here? 2 to the power of 3 is what? 2 times 2 times 2 times, good, right? So we're just taking 2, we're multiplying it by itself 3 times, right? And so it's going to seem kind of pointless what I'm doing right now, but it's once we go into the next few examples. If I do 2 to the power of 3 times 2 to the power of, let's say, 4, I mean, let's do 2, right? What's 2 to the power of 3? 8, right? What's 2 to the power of 2? 4, right? So this is what? 32, good. So what's actually happening here is we're adding the exponents, right? So we're doing 2 to the power of 3 plus 2, right? So this is 2 to the power of 5, and that's 32. 2 to the power of 5 is 32, right? It's like it's 2 times 2 times 2 times 2 times 2. It's 4 times 2 is 8 times 2 is 16 times 2 is 32. So let me just, why am I showing you this for this specific, why am I showing you this specific thing right here for this specific example? So if I do 2 to the power of 0 times to the power of 3, right? It's going to be 2 to the power of what plus 0 plus 3, right? And that's 2 to the power of what? 3. That's 2 times 2 times 2, which is 8, right? 2 times 2 is 4, times 2 is 8 here. So the value of 2 to the 3, we've already established over here, it's 8. What's the value of 2 to the power of 0? 1, right? That's what we're trying to get at. 2 to the power of 0 is 1. Right? Anything to the power of 0 is 1, right? And so just wanted you guys to understand for the later example in this file. Okay, so now let's do an exponent problem to calculate the exponent, right? So function, call this traditional way 1. Function, we'll call it calc exponent base exp right here, and say I have var p equals 1, right? Var p equals 1, this, and then we return p. And over here, let's say I have a for loop. A for loop, right? Because I have to multiply p by base a certain number of times, right? The base is, let's just say the base is 2. Base is 2, and the exponent is 3. If the base is 2 and exponent is, so 2 to the power of 3, what should p return? 8, right? Just like before. So we start off, p is now 1. We need to turn 1 8 using this for loop, right? So using this for loop, we need to turn p into 8, right? So what goes here and what goes here? I'll let you try that right now. What you think about it? Give you 5 minutes. Two more minutes. Just trying to figure out what should this be and what should this be right here. All right, guys. So what be inside this for loop at the top on line 24? Let's go to Josh's row.
I 0.
Perfect.
I was thinking I is less than exp.
Perfect.
I plus plus.
Because we need this running 3 times, right? Because 2 to the third power is 2 times 2 times 2, right? So we need to do 2 3 times in this. And then over here, we're going to do P equals what? Good. P times base. Right here. P times base. Right? So P stands for the product, right? So I'm just write product. And we're gonna take 1. 1 the base is 2. And that goes into product. And then on the next iteration, we take 2 times the base, which is 2, multiply together, it's 4. So now the product is 4. And then we take 4 times the base, which is 2. 4 times 2 is 8. And then that's the product right here. And we return the product. Question on this right here.
So we should do something for if the exponent is 0.
No, yeah, you're absolutely right. Over here, if exponent equals return 1. Nice. Right, otherwise, it's just going to go over here.
Do you have to do that?
Do I need to?
If it's
Oh, you're right. I don't have to do that, right?
exponent would already
Be 1, and if
equal to 0.
if exponent, you're right. If exponent was 0, then this for loop run. It skips over the loop and returns the product. Interesting. And, yeah.
Why don't you change line 25 to, instead of doing product on space, we do shorthand.
Oh, shorthand. So this is one way of doing it. And then there's another way would be product times equals base. Right, so this is just a shortcut to this right here. Perfect. Okay, there's another way of writing this that's a little bit easier. It's a traditional way too. Function, the same thing almost. Earn in one line. Does anyone know it? Math.pow. I finish it off. EXP right here. So you could do it in these 2 ways right here in this way. And both these ways are better next way I'm going to show you, right? So I'm going to show you how to use recursion in this example. Recursion, sometimes in interviews, they ask you to solve a problem with recursion. And if you haven't done it before, it's basically extremely difficult to just think of it on the spot. It's just basically impossible to think about it on the spot, right? Unless you've practiced it a few times. But recursion really takes it takes a lot of iterations. Like this for loop is actually pretty good. It doesn't that long to run this for loop. Because in this example, if I pass 2 and 3, how many loops does it do? 3. It has 3 iterations. Whereas with recursion, it would do much more. It would do more than 3, right? So this is how you solve the problem with recursion. With recursion, let's take a look right here. So on the surface, it looks very similar. Let me just change the function call. On the surface, it looks very similar. We have a base, we take an exponent, right? And then I have two things right here. If exponent equals 0, I'm returning, that's wrong, 1, right? That was bad. Oh well. If exponent equals 0, return 1. If exponent equals 1, returning base. So can someone explain these 2 lines? Why do I have line 47, 48 here? Well, can you explain line 47, 48?
In 2 cases.
Why do we have line 47 here?
Because the power of 0 is 1.
Anything to the power of 0 is 1. What about line 48?
1 will be itself.
Good. Anything with 1 is going to be itself, right? 2 to the power of 1, 2, right? 5 to the power of 1, 5. right? Okay, so this else, this is the confusing part, but every recursion problem is the same thing, right? Every recursion problem works the same way. You have your basis, then you call the function, then you return a modified call to the function.
When he says modified, you mean like they reduced the version of it one, or we're gonna keep subtracting.
Or going up, right? Yeah. So your this -1 is the modification. So over here, right, we're returning base times. We're doing base times the function call, and we're passing in base comma exponent -1. So what's happening here? So let's pass in. Let's go ahead, call calc exponent 5, 3. Right? If we call this function right here 5, 3, right? What's the wave exponent? 3, right? So 3 is not equal to 0. So this doesn't happen. 3 does not equal 1, so this doesn't happen, right? So we go to the else, right? So what do we return? What? Right, 5 times calc exponent 5, 2, right? So this is what happens right here. So again, right, we're passing 5, 3. So over here, the base equal to 5, and the exponent is equal to 3. Right, these two are, the base is equal to 5, this exponent is equal to 3. So because the exponent does not equal 0, it's 3. Exponent does not equal 1. These two if statements don't run. This else runs. So we return this, which is 5, times the function call, comma, the function 5, and 2. Right? Yeah, you see it right there, right? And so now we look at this function call right here.
Go down 1. So you have the 5, and then your expo will go down to 1 in the next iteration.
Exactly, right? So over here in this case right now for this right here, we're doing 5, right? The base is 5, the exponent's 2, right? This exponent is not 0, it's 2. The exponent 1, it's 2. So we go to this base, we go to this else block right here. And then over here, it's like we do 5 times the function calc exp, the base, which is 5, comma, the exponent -1, it's 2 minus 1 now, right? 1. And then this one, the function call 5, 1, the base case is 5, and the exponent is 1. The exponent 1 is not 0, so this doesn't happen. Wait, this is true. 1 equals 1, so we return the base, right, which is 5. So this becomes 5 times 5 times 5, right here, which is 125. So when you have like recursion, you have your base cases, and then you have a modified version of your function call that eventually goes back to your base case. It eventually goes back to your base case, right? It's like a for loop, but in a weird way, right? And why, like, what's the point of this, right? Why even do this? Why are we even learning this if this way is kind of stupid to this way? This way is better. It takes less time, right? Because sometimes it's worse to do this way. Like, there's no other way to solve the problem other than this way. And the situation when that occurs, and this has happened to me, right? So you have a nested object, right? You have a key colon, an object, a key inside of it, right? It's an object. And then let's just say you have a key inside of that, it's an array, and that has an if inside of that, right? And that object has, let's say, a key and an object, right? And you're thinking like, well, why would that ever happen? Because people suck. And in media math, I dealt with this API. Has anyone NetSuite? You've heard of NetSuite, right? So NetSuite's this like endless finance tool for like the finance teams, right? To do invoice management. Amazing tool, but they don't care about developers. So they made their API terrible so that it returned random stuff, right? So it would return this nested object that would constantly change. Sometimes it was an object, sometimes it was a string, sometimes it was an array of objects, and the object itself arrays an object inside of them, right? So I never knew what it would return. So it was very hard to work with. So I had to make a recursive function to search through where the information was inside the object, right? And although that use case isn't always going to happen, right? Sometimes you're going to deal with nested objects, like nested JSON. That's very common. And then if you want to find something in it, you have to use them. There really is no other way. It wouldn't be as simple as this right here, although this isn't simple, but it wouldn't be as this. It would be a little bit longer, but you can't use for loops for that because you don't know how many for loops, right? You don't know, like, you would have to put like 100 for loops just to ensure that you hit the nestedness, right? And that's not, yeah, exactly. Then it would take forever to run. It would crash the server. So sometimes you're forced to do this right here. Bots, yeah, a lot of bots are recursive. Yeah, but then they get annoying.
The functions we saw that's parse.
Mm-hmm.
I think that might use something.
Yeah, maybe. I mean, JSON.parse kind of just like takes all of it inside. Yeah, maybe. Yeah, you're right. Interesting. Didn't think about it like that.
Going down the nested, you still have values.
You know what? I feel like it's faster. If it was recursion, if it used recursion for that, it would take a little while. For one, it's pretty fast, so I would imagine it doesn't use recursion because of how fast it is. Yeah. Sorry for destroying your minds today. And take care, Josh.
Mine needs to be destroyed.